Hello, I'm W.P. Suazo, and I'm here to talk about game theory. The first thing I want to establish about game theory is reading a duopoly payoff matrix. Duo means two, so this is a duopoly payoff matrix. This shows the payoffs for two parties. The way I always pose it is you versus your rival. So here you are on top. Since you're on top and a bit to the right, each of these four cells, if you look at this as a window graph, each of these four quadrants, your payoff is always on top and a bit to the right. So these are all your payoffs. If you're on top, these are all your payoffs. Okay, so conversely, since your rival is to the left and a little lower, all the payoffs in each cell that are to the left and a little lower are the payoff to the rival. Okay, so what happens? Both of you have two options, A and B. A and B. So 2 times 2 equals 4, so we have 4 prospective outcomes. What happens if both you and your rival choose A? That describes the northwest quadrant. What happens if you and your rival both choose B? That is the southeast quadrant. The northeast and southwest quadrants are hybrids. That's when you and your rival act or behave differently. So what happens if only you choose B? Or as it's described here, rival A alone. So if your rival chooses A alone, that implies that you choose B. Well, if he's choosing A and you're choosing B, this is the payoff to you, and this is the payoff to your rival. So this is how a duopoly payoff matrix works. The last hybrid cell down here, it says U, A alone, U, A alone. So you, if you opt A alone, that implies he's going B. So you choose A, he chooses B. This is the payoff to you, always to the top and a bit to the right, and this is the payoff to him, your rival, always low and to the left. Okay. Symmetry. Symmetry in a duopoly matrix is when the payoffs are perfectly symmetrical, when they are perfectly symmetrical. So what it means is that if you get A here, he also has to get A. And if he is paid B here, you also have to get paid B. And if you're paid C, when you're opting A alone, then he has to be C. He has to be paid C when he's opting A alone. And this would be D, and this would be D. And what does D represent? When you opt A alone, D is the payment to him, or when he's opting B alone. This is what symmetry looks like. Symmetrical, I'll call it. Where, I'll write this as low as I can, where A may A equal B, may equal C, may equal D. Okay. May, not a requirement, where A may, where, okay, so we have symmetry defined. Okay, I used to do this with classes with the matrices already filled out, and that was a horrible mistake. The most difficult thing about game theory matrix is actually filling it out. So I'll give you another matrix here. I'll give you another matrix here, and we'll erase that as soon as we're done with it. Okay, so we have this here. This is the line of symmetry. So we just got done with symmetry. You can think of this as the mirror's edge. So now I am using prisoner's dilemma. I'm using prisoner's dilemma. So what I'll have as the two options is cooperate or invoke the Fifth Amendment to the Constitution. So here's you, and here's your rival. He may also opt to cooperate with the authorities or invoke the fifth. All right, what does it say? If both of you cooperate, both get 4 years in jail. So, cooperate, both get 4. So far it's looking symmetrical. If both of you plead the fifth, you plead the fifth and he pleads the fifth, both get 3. So far it's symmetrical. Will it stay symmetrical? Let's see. You fifth alone. This says you fifth alone. If you plead the fifth alone, that means he's cooperating. If you plead the fifth and he pleads the fifth, we've already covered that scenario. So if you plead the fifth alone, that means he's cooperating. You get 10, so you are up and to the right, and he gets 1. Now for this to be symmetrical, this would have to be 1, and that would have to be 10. But as you are seeing, that is not the case. If your rival pleads the fifth alone, which means you do something different, which is cooperation, you get 2 years in jail, and he gets 3. Okay? So that is our matrix. And this is probably the toughest part of game theory, filling in that matrix correctly. All right. Now, let us ask some questions about this matrix. Question number 1. Is this matrix symmetrical? Is it symmetrical? And as we just concluded, no, it is not symmetrical. All right. What is your best course of action? What is your best course of action? To cooperate or to plead the fifth? If we just take mere averages, 4 and 2 is 6. So that's an average of 3 years in jail, or just add up the jail time. So if you cooperate, you're facing 6 years of jail time. If you plead the fifth, you are facing 13 years of jail time. So your best course of action is to cooperate. What about your rival's best? Your rival's best is what? So he's being posed with 5 years in jail or 6 years in jail. So he too will cooperate. So maybe you have a criminal history and he doesn't, because he's being posed with less years in jail. Now, are these best strategies dominant strategies? For a best strategy to be a dominant strategy, a best strategy is a dominant strategy if it never offers a worse payout. So, the best strategy is a dominant strategy if the other strategy does not have a better payout. So let's look at this here. You chose to cooperate. Is 4 years in jail worse than 10? No. Is 2 years in jail worse than 3? No. So your best strategy is indeed dominant. Big check mark there. Your rival opted to cooperate as well. Let's test his. Is 4 years in jail worse than 3 years in jail? 1 year in jail is not worse than 3, but 4 years in jail is worse than 3 years in jail. So your rival's best strategy is not dominant. Your rival's best strategy is not dominant because here is that worst payoff staring us right in the face. All right, what is the probable outcome? What is the probable outcome? The probable outcome is the cell shared by both best strategies. So the probable outcome is the cell shared by both best strategies. The best strategies are circled in these ovals. So the probable outcome is both get 4 years in jail. So both parties are going to get 4 years in jail. Is this probable outcome a Nash equilibrium? Okay. What does Nash equilibrium mean? Nash equilibrium can be explained in many ways, but perhaps the shortest way to explain Nash equilibrium is that both parties are settled down. Both parties are content. And Nash equilibrium is when both parties are content. Or you could say when a second chance is worthless to both parties. If you could say to either yourself or the rival, hey, I'll let you decide now, I'll let you make a second choice now that the other guy has already went. If both parties say no, a second choice is worthless, or if both parties are content, we'll have Nash equilibrium. We look at you. Now you might say, well, the payoffs to me are 4, 10, 2, and 3. With a Nash test, the first thing you have to do is exclude what is no longer possible. I say again, with a Nash test, you must ignore what is no longer possible. For you, 2 years in jail and 3 years in jail are no longer possible ever since your rival cooperated. So you must look at 4 and 10. You are only, what's possible now is only 4 and 10, and as it so happened, you chose 4 over 10, you are content. If you look at your rival, we see 4, 3, 1 and 3 as his payoffs. For your rival, 1 no longer is possible. It's no longer possible because your cooperation has made it impossible. So your rival has to look between 4 and 3. As it turned out, your rival chose 4. He is not content. He wants to choose again and move this way. So we do not have a Nash equilibrium. We don't have peace. Both parties are not content. All right. The final test is this. Is there a collusion opportunity? A collusion opportunity improves payoffs to both parties. A collusion opportunity improves payoffs to both parties. Okay. So we look at this right here. We have 4 and 4. For this matrix, we have 2 collusion opportunities. Anything that requires your rival to plead the 5th is better than what's going to happen. If you could, after you're taken into custody by the police, if you could communicate to your rival, hey, please, just plead the 5th. If you plead the 5th, both of us are going to be better off. That is certainly the case, because both of you go from 4 and 4 to 3 and 2, or from 4 and 4 to 3 and 3. So a collusion opportunity is simply something that improves the payoffs for both parties. So there is a collusion opportunity, and what does it require? It requires rival to invoke the 5th Amendment. I know that looks like an 8. It requires a rival to invoke the 5th Amendment. So what does it get? It gets your rival 3 years in jail, and it gets you. To you, you either get 2 or 3, depending on your own action. Okay. So this is game theory being done with Prisoner's Dilemma. It's quite a topic. Let me try to stand out of the way of everything. It requires much explanation. I hope this has shed some light on the topic, and thank you for watching.